Good afternoon, Manada. So now I would like to say something about industrial electrical systems too. So this is nothing but module 5. So module 4 is nothing but industrial electrical systems 1. So module 5 is nothing but industrial electrical systems 2. So in this now we are discussing about select the UPS and selection of the UPS. Select the UPS is the different and selection of UPS is the different. So and next, calculate the battery bank capacity and account for their characteristics, and next consider the other factors, and next elevators, next core components of the elevators, and next DC systems. DC systems is nothing but distribution generation, and next batteries and battery function examples, and next UPS is an uninterruptible power supply and their function components, and next so types of UPS batteries, next other types. So these are that we are discussing today in the class. So now first of all I am taking that here. Select the UPS unit. Select the uninterrupted power supply unit. So how to select that UPS? So the select that UPS. So first of all here some characteristics is there. How to select the UPS? First one, match the capacity and consider UPS type, which type of UPS is required, and next check battery compatibility. So here now I'm taking first of all match capacity. So here the match capacity of a UPS, choose a one UPS. So now we are choosing one UPS with a volt ampere rating, in that volt ampere rating. So it is equal to or greater than the total calculated the load including the safety margin. So this is nothing but match capacity of the UPS. And next, consider UPS type. So consider the UPS type. Here select that UPS type, for example offline or line interactive or online. So these are that, select the type of UPS. So that best fits in your needs for power protection and efficiency. So this is that, consider UPS type. And next, check battery compatibility. So the check battery compatible, ensure that battery or UPS model is that compatible with the type and number of batteries you plan that to use. So this is that, select the UPS unit. And next, selection of UPS. Select the UPS is the different and selection of the UPS is the different. So now we are discussing selection of UPS. So how to selection of the UPS? So to select them, to select a UPS of and battery bank, so first determine the total power requirement, so in that volt amperes only, so of the devices to be protected, and the decide how much runtime. So then the calculated required UPS capacity, ensure a safety margin, for example up to 20 to 30%, and select a UPS unit with a necessary volt amperes runtime specifications. So here finally calculate the specific battery bank and capacity by considering the factors like UPS efficiency and battery voltage, design margin, and aging. So these are the types of factors selecting the selection of the UPS. And next, so calculate the battery bank capacity. So here calculate the battery bank capacity, calculate total wattage. So here calculate the total wattage. So in that, convert the UPS volt amperes rating into watts by multiplying it the power factor. So the power factor typically around 0.8. Okay. So next, so account for efficiency. So and the calculate the battery bank capacity, wattage is over, and next account for efficiency. So in that account for efficiency, so divide the total load in watts by the UPS efficiency to find the normal efficiency battery load in watts. So next, determine battery voltage. So that determine, so how much that battery voltage we can determine that. So determine the battery voltage, deciding on the system voltage or for the battery bank. So adjust for factors. So adjust the normal battery load by multiplying it by an design margin and aging factor and temperature correction for to get adjust battery load. And next, here calculate total ampere hours AH. So calculate the total ampere hours AH. So divide adjusted battery load in watts by the battery to find the required ampere hours. So these are that calculate the battery bank capacity. Next, consider other factors. So what are the consider other factors in that? See, criticality, first one. Next, space. Next, budget. Next, last one is nothing but maintenance. So here criticality. So how much percentage here the criticality? So for every critical applications, a redundant UPS configuration may require to ensure continuous power in if even one system fails. So that is that criticality, related criticality. So next, space. So what is the space here? Ensure you have enough physical space for the UPS and battery banks. And next, budget. So budget, higher capacity, more advanced UPS systems and larger battery banks will increase that cost. And next, last one, maintenance. So the maintenance, consider complexity of maintaining the chosen configuration, as more complex systems can be harder to maintain. So these are the 4 factors considering that in UPS and battery banks. Next, elevators. So what is the elevator? So here the elevators, an elevator's electrical system is a complex network of circuits that uses an electric motor to power vertical movement and manage the cab's operation. So the key components here include the main power supply, a over control system of all for all functions, and various safety circuits that manage over speed braking and emergency power. So the core of the system is an electric motor connected to a traction sieve, which uses ropes and a counterweight to move the elevator core efficiency and smoothly through the shaft. So what are the core components of the elevator? So the core components of that elevator: electric motor, traction machine. So how to control the system? So how to control the system is nothing but the control system. So in that, the core components, the 3 core components involved in that elevators. So first of all, here electric motor. So basically here the motor is nothing but electrical energy is converted into mechanical energy. Suppose vice versa is nothing but generator. So generator mechanical energy is converted into electrical energy. But here electric motor, the core components of the elevator. So first component here, electric motor. Here the electric motor is the heart of the system and converting electrical energy into mechanical motion needed to lift the cab. So this is the electric motor. So next, traction mission. So the traction mission, this includes the motor, the sheave. The sheave is nothing but a grooved pulley, and the gearbox. It drives the ropes to move a car. And next, last one, control system. How do we control that? So the control system, a complex control board manages in all elevator functions, including the motor, speed, door operation, and the destination request from the passengers. Next, DC systems. DG, not DC, DG systems. DG systems is nothing but distributed generation. So, suppose in an electrical industrial systems, industrial electrical systems, in an industrial electrical system, the DG systems refer to two main concepts. So, what are the two main concepts here? Distributed generation and diesel generators. So suppose here distributed generation, which are small power sources near the point of use like solar panels or micro turbines, and diesel generators, so which are fuel based system used for backup or primary power. So the DC system helps improve reliability and reduce energy losses and can incorporate renewables. So diesel generators a common type of DC system. So our compression ignition engines that use a diesel engine to drive an alternator to produce electricity, providing a reliable backup power source during grid outages. So next, batteries. So here the batteries, basically the battery is nothing but chemical energy is converted into electrical energy. So there are so many types of batteries, but here the battery should last 3 to 5 years before any significant degradation. Suppose for large outages, if you expect long duration power cut hours, remember that typical UPS is meant for short term. Short terms is nothing but not seconds, in minutes to allow safe shutdown or start generator. If you want long run time, you may need external battery modules or a full inverter plus battery bank. So the outlet plug compatibility. So outlet plug compatibility ensure the model you buy has Indian plug format only. So Indian plug format 230 volts and 230 volts, 50 hertz. So this is the range and enough outlets for your devices. So next, battery function examples and its role. So the battery function, it stores electrical energy in the form of DC power using a chemical process. So simply called as chemical, the battery converts chemical energy converts into electrical energy. So that is the battery function. And next, for example, for battery examples can range from small coin cells motherboards to large industrial battery banks. So role, so what is the role of the battery? So it is a component that provides to store power, but its role depends on how it is used. So on its own, it is just an energy storage device. Next, I'm taking here UPS, uninterrupted power supply. So the function, components, battery, inverter, charger, control circuitry. So here function, first of all function, after the components. So what are the components involved here? Battery, charger, inverter and control circuitry. So first of all we'll see that function. So here the function, it provides immediate or temporary power to connected devices when the main power source is interrupted. So it also often provides the power conditioning to protect against surges, sags and other power problems, if any other power problems. So next, components. The components, battery. So the battery here purpose, it stores the DC power only, not AC power. It stores the DC power. And next, inverter. So inverters. So inverter is nothing but the DC to AC. So here simply called as inverter. It converts the battery DC power to AC power for the connected devices. So this is the DC to AC is nothing but inverter. Suppose AC to DC is nothing but rectifier. Next, charger. So the charger, it keeps the battery charged when the main power is available. And next, control circuitry. So control circuitry, last one, control circuitry manages the power flow switches between the main power and the battery. So next, the main types of UPS batteries. So the main types of UPS batteries are lead acid and lithium ion, and other types includes nickel cadmium and nickel metal hydride. Through the lead acid and lithium ion are the most common in modern systems. So next, other types. So here the other types, nickel cadmium. So nickel cadmium and type of battery known for its durability and performance in extreme temperatures, nickel cadmium. So and next, nickel metal hydride. So nickel metal hydride, less common but a more environmentally friendly operated compared to nickel cadmium. So next, last one, lithium iron phosphate. So the chemical name is LiFePO4. So a type of lithium ion battery often used when high cycle stability is needed. So here, so these are the other types. The other types is nothing but here, nickel cadmium and nickel metal hydride, lithium iron phosphate. So these are the other types batteries. And next we will see the next class. So that is nothing but industrial electrical systems too. So few more topics. Thank you.